PFAS in food and packaging, an emerging food safety issue. PFAS, per- and polyfluoroalkyl substances, are forever chemicals that have been linked to significant human health problems and increased risks of chronic diseases like cancer. PFAS chemicals are present in food, drinking water, and food packaging materials. And just a note as I read out this article, I'm going to use the word PFAS, the acronym PFAS. It's a plural and a singular together because it stands for per- and polyfluoroalkyl substances. And so I'm not going to say PFASs because it sounds awful. Anyway, so PFAS, plural and singular. This month, a new study showed that wild-caught US freshwater fish are much more contaminated with PFAS than was previously thought. Eating just one serving of the fish is as dangerous as drinking heavily contaminated water every day for a month. PFAS exposure can lead to decreased fertility, developmental delays in children, increased risk of kidney, prostate and testicular cancer, immunological defects, and increased risk of obesity. And as always, you will find sources for everything that I say here in the email and the article. And in this particular article, there are so many links sprinkled throughout the text as well. So go back to the written content if you want any sources. The main exposure routes for adults are drinking water and eating food. For food professionals, the presence of PFAS in municipal water supplies, fish, and food packaging materials are emerging as food safety hazards that need to be considered in food safety plans. Background. PFAS are a group of man-made chemicals that have been widely used in a variety of industrial and consumer products since the 1950s. These chemicals are known for their ability to resist heat, water, and oil, which is why they've been used in products such as non-stick cookware, water-repellent clothing, and fast food wrappers. However, PFAS are also highly persistent in the environment and accumulate in the bodies of animals. Most people worldwide have PFAS in their bodies, with more than 98% of Americans having detectable levels of PFAS in their blood serum. Among the PFAS family of chemicals, some are more toxic and more able to bioaccumulate than others. Two such toxic versions of PFAS are, I'm going to call them PFOA and PFOS. And those two acronyms, PFOA stands for perfluorooctanoic acid and PFOS stands for perfluorooctane sulfonic acid. Some PFAS have been shown to cause developmental problems, cancer, and other health issues in laboratory animals. Studies in humans have also found associations between PFAS exposure and certain health outcomes, such as high cholesterol, decreased fertility, and immune system effects. So what's changed lately? Why are we worrying about this now? Well, lately the good news is that some PFAS chemicals are being phased out or have ceased manufacture altogether. Human exposure to the older and most heavily regulated PFAS, which are PFOA and PFOS, seems to be decreasing. However, exposure to the newer chemical, PFNA, and that stands for perfluorononoic acid, seems to be increasing. So exposure to PFNA seems to be increasing, and the health effects from PFNA are perhaps as bad as the ones from the older chemicals. In a survey of the US population, the concentrations of PFNA in blood serum doubled in a recent 4-year period. Levels of novel PFAS chemicals are also increasing in the blood of European populations. New studies, including one just published about the prevalence of PFAS in fish, are raising alarm bells because higher than expected levels of PFAS have been found. Government monitoring of PFAS typically reports much lower levels in food, water, and the environment than are being found by other scientists. Freshwater fish is an emerging concern for PFAS contamination of food. Certain regions and fish types in the USA appear to be heavily contaminated compared to the results obtained in regular government monitoring surveys. In the US, there have been two new lawsuits filed against food chain businesses in recent months because of the presence of PFAS in their products. You may have seen these in the Rotten Apples January Food Safety News Roundup. One such lawsuit is against a firm that deliberately creates PFAS chemicals in plastic packaging to make it stronger, using a process called fluorination. The other lawsuit is against the owner of an orange juice brand that is marketed as natural, but that contains hundreds of times the concentration of PFAS that would be acceptable in drinking water. Oh dear. In Europe, the European Union has classified PFAS as an emerging chemical risk. Public awareness about the risks of PFAS in food and water is increasing all around the globe, and the World Health Organization is currently developing guidelines for PFOA and PFOS in drinking water. PFAS and food. PFAS can be found in foods including fish from waters that have been contaminated with PFAS, as well as dairy foods from cows exposed to contaminated feed or water. Food packaging is also an exposure route for PFAS. Freshwater fish are emerging as particularly risky food with respect to PFAS consumption in most regions globally. PFAS chemicals can leach from food packaging materials into food, with paper-based packaging being the most risky, especially when the food is held at warm temperatures. PFAS are intentionally added to the greaseproofing agents and coatings used on some paper and paperboard food packages to impart oil and moisture-resistant properties. Package types that are most likely to have PFAS are grease-resistant paper, pizza boxes, fast food containers, microwave popcorn bags, and sweet wrappers. The chemicals can be present in the packaging materials at significant levels. For example, researchers reported finding PFOA, and that's one of the bad ones if you recall, in a microwave popcorn bag at concentrations up to 300 micrograms per kilogram. That's almost a third of a gram. A significant proportion of these chemicals can migrate into food. In one study, researchers placed food-approved paper into contact with food simulants at 40 degrees C and discovered that at least 5% and up to 100% of perfluorocarboxylic acids, which is a subclass of PFAS, migrated from the packages into the food simulant during 10 days of storage. It's not just warm foods that pose a risk, though. Another study, which used microwave popcorn and butter, found measurable migration even during cold storage of the butter. The study's authors reported that the presence of emulsifiers in food enhances the migration of the chemicals from packaging and suggests that using food simulants which do not contain emulsifiers for food safety testing may underestimate the risks. Rules and regulations. Most regulations and guidelines internationally use values for just two PFAS chemicals, PFOA and PFOS, because they were used in larger quantities in the past and have been found to be persistent in the environment. In the US, the Environmental Protection Agency, EPA, has established rules for monitoring PFAS in drinking water, and some states have regulations covering the use of specific PFAS compounds. A number of US states now prohibit the sale of food packaging which has had PFAS intentionally added. Limits for PFAS in drinking water have been set by some states as well. The European Chemicals Agency, ECHA, has classified some PFAS as substances of very high concern, and the European Union has established maximum levels for PFOA and PFOS in food and feed, as well as banning the use of certain PFAS in consumer products, including textiles and leather goods. In Canada, some PFAS chemicals are regulated as toxic substances, and there are maximum acceptable levels in drinking water for PFOA and PFOS. The Japanese government has established a maximum level for PFOA in drinking water, and there are regulations governing the use of PFAS in food packaging and textiles. The Vietnamese government is also planning to prohibit the use and production of PFAS in food packaging and textiles. Singapore, the Philippines, Australia and New Zealand have also set limits or guidelines for acceptable levels of PFOA and PFOS in drinking water. What to do now? For food professionals, PFAS are a concern, but an issue that is difficult to manage. There are no easy ways to avoid PFAS chemicals in food and water from areas that have been contaminated. However, if you work in a food business that purchases, utilises or sells packaging materials, or water or fish, you should consider how much PFAS are in your supply chain. Food contact packaging may contain accidental or deliberate quantities of PFAS chemicals. If you purchase packaging, you should seek information from your suppliers about the presence of PFAS in their products. If you're a member of the International Association of Food Protection, IAFP, you might find this thread on the IAFP forum useful. There's a link, of course, in the email to that thread. It contains links to a list of US state-based regulations for PFAS in food packaging. Water used in food manufacturing processes may contain PFAS, including potable water from municipal supplies. An independent study of municipal water from 44 locations in the USA found detectable levels in all but one sample, with some city water supplies above advisory levels set by the US EPA of 70 parts per trillion or 70 nanograms per litre, and those levels are for PFOA and PFOS. In Asia, 100% of water sampled from the Philippines and Thailand, and that was 46 samples in total, contained detectable levels of PFOA and PFOS. Some areas of Europe have concerning levels of PFAS chemicals in their drinking water too. Seek information from your water supplier, or even organise your own test to ascertain the concentration of PFAS chemicals in your water. Manufacturing processes that result in water impurities being concentrated in the finished product, such as by dehydration, cooking and frying, are more vulnerable to risk from PFAS in the water supply. Fish can contain high levels of PFAS, with some regions and some species more at risk than others. For example, freshwater fish from the Great Lakes region of the USA have levels 24% greater than freshwater fish from other parts of the United States. Review your food safety plan and consider adding PFAS chemicals to the hazard analysis for at-risk inputs such as water, fish, and packaging materials. In short, consumers and regulators are becoming more aware of the prevalence and dangers of PFAS chemicals. Lawsuits are occurring in the USA against food industry operators over the presence of PFAS in products and packaging. The European Union considers PFAS an emerging health risk. PFAS get into food from raw materials sourced from contaminated environments and by migrating from packaging materials that contain intentionally added PFAS. There is robust scientific evidence about the dangers to human health from PFAS. Food safety risks posed by PFAS hazards should be considered in food safety plans. And I've included a link at the end to read more about PFAS in plain English on the US EPA government website.